Good morning, everybody. Welcome to Overcast. Hold on, let me reboot. Good morning, everybody. Welcome to Overcast Wednesday morning with your host, me, Dr. White, for another adventure in chemistry, Chem 1211. Howdy. All right, important things. First of all, you should have gotten two emails from me because I made two announcements. Let's go through those announcements. All right, does everybody see final deadline on your screen? Thank you. Thumbs up, people. All right, as I mentioned on Monday, I have created a late labs assignment area, which has a list of all the labs that have been done, or actually the files, PDF files, all labs that have been done this semester, except this week's and last week's. And what I mean by last week, the one that's due today, because you can still download that. You have until Saturday, this Saturday, 10 a.m. If you go to Blackboard, you see a zero, upload the lab you're missing completed to that area. You can do more than one lab to that area, and a few of you need to do that. After that date and time, any labs that have not been handed in, I will give you 0 points. So this is my last get out of jail chance for you. For those of you who are falling behind, here it is. If you need help with any lab, either come to my office hour tonight or stay after lab if you have on Thursday, on Friday. All right, second announcement I posted yesterday is for test number 4 information. Test number 4 will be given a week from today, Wednesday, 5/5/21. And like the other tests, after class around 12:30, I'll email you the password for test number 4 PDF file. And on probably next Tuesday afternoon, I'll post test number 4 in the assignment area so you can download it early if you want to. You just can't open it up. Now, you'll have, just like last time and the time before and before, till next day, Thursday morning, to 10 a.m. to take the test and upload it as a single PDF file. Be sure you check each page on your PDF file that you have all your answers. Last test, a couple people did, and I was nice enough to go back and say, hey, you forgot to do this. Please check. Test number 4 has 9 pages, 18 problems. Some of the problems have multiple parts. I don't think I have any multiple choice on this test. Deals with chapters 14 and 15, which deals with rate of reaction, equilibrium. I didn't put it down there, but that's Le Chatelier's principle too. Acids, bases. Here are the point breakdown. On the chapter dealing with rates of reaction equilibrium and with Chandler's principle, there's 41 points. Acids base, 64. Why more in acids base? Because it's more important. Please note, the extra credit project deadline is this a week from today. It's optional, but before that deadline, come to my office hour, email me with your project. I'll check it and tell you what you have to correct so you can get your 10, yes, 10 bonus points if you want them. And in terms of the test, make sure you upload it properly and follow instructions, or I reserve the right to subtract up to 25 points as anybody who doesn't. And the rest is standard. Remember, next Wednesday, I will still have a normal Zoom lecture. And as I say here, by the Sunday after the test, by 1 p.m. or earlier, I will have on Blackboard your grades, and sometime that day or by Monday at the latest, I'll also send out an email with your individual points for each part of test number 4. And that was sent to you as an email, and it's also obviously announced in Blackboard. Any questions on either of those topics? I'll look at the chat.
I have a question.
I do questions. Yes, Kelly.
How much of a percentage of the test does it count for our overall grade in the class?
Good question. And I have an answer. Hold on while I open something up. Kelly, do you see on your screen evaluation percentage? This is in the syllabus, page 16 of the syllabus. What I will do when it comes to your final grade, and not only you, but every student, I tell you, I pick favorite students in my class always. All of my students are favorite. All right. In other words, I don't have favorites. I try and treat everybody equally. Try hard too. All right. You're going to have 4 tests. You take the sum of the 3 highest test scores, and that's 47%. So if you're interested in the test score percentage of those 3 tests, divide 47 by 3. That's what each of the 3 tests I use are worth. Your final exam is 32%. Your lab is 21%. And lo and behold, it adds up to 100. Actually, students could get higher than 100 because I have bonus points on my test, on the final, and the extra credit. And I've had students get 105%. Does that answer your question?
Yes, thank you.
You're welcome. I try and make, and by the way, if you're wondering how to get your grade, here's the percentage calculation. Sum of the 3 highest hourly exam, plus the final exam, plus the lab total. If you do extra credit, plus those, times 100 divided by 630, gives you a percentage. If it's 90 and above, 80 to 89B, 70 to 79C, 60 to 69D. Hopefully nobody's below this area, but less than or equal to 59F. And as I said, I think I mentioned, I think it's going to be higher in this class, I hope. But if you've done the practice problems and you're doing well on tests, usually about 60% of my class, important word is earns an A. And I think in this class, a lot of you are doing very well, which makes, hold on, to go full screen on this. A lot of you are doing very well, what makes Dr. White feel oh so happy. Thank you, and thank you. All right. I think we better get back to chemistry. And I've got a surprise for you. Everybody see my whiteboard, which is totally white? All right. Since we're in a good space, I should mention before I get into this, all right, Thursday and Friday, I'll be going through the equilibrium rates of reaction problem set. Next Monday, I'll go through the acid-base problem set, plus my world famous review for test number 4 on Monday. Also next Wednesday, I'm not going to do it today. Next Wednesday, I'll have time at the end of class or beginning. I'll think about it on Monday. I'll let you know. I will teach you the secrets of how to do a good interview. If you're going to interview for a job, which I assume all of you will at some time in your life, or if you're going to interview to get into school or a program, which many of you will do, I'll teach you some secret. Hold on, my colleagues come up. Oh no, I'm having a bad hair day. Don't look. Anyways, I gotta go find a hat. Hold up, no. But anyways, I'll do that next Wednesday. And from the couple of years, I've only doing it about 3-4 years, it's made a big impact and helped a lot of students. All right. Now, let me just get rid of that. In the previous chapter, talked about energy diagrams, and you should know how to do this for an exothermic reaction. Now, how do you know this is exothermic? I have an equilibrium here. I could just as easily have done this. Either way, it's the same. I'll do it just a regular reaction. If heat is on the product side, the right side is exothermic. Exothermic means it gives off heat. Also remember that an energy diagram, ooh, I'm doing better straight lines today, look out. On the y-axis, you have energy. The x-axis, you have time. In case you forgot, this is y, this is x in a graph. And A and B have a certain amount of energy. And you don't have to put the coefficients if there were. If you do, no problem. Doesn't bother Dr. White, and I'm the one grading the test. Now, there's a concept in chemistry that you never create or destroy energy. So the total energy of this side equals the total energy on that. But notice some of the energy is being lost as heat. Therefore, the question you have to ask is, does A and B have more or less heat than C and D? Well, since some of the energy on the right is lost, C and D have less energy, which is why I'm drawing it lower than this. And going from A and B to C and D, you go up a hill and over all the way down the hill to grandmother's house you go. And from where you start to the top of the hill is the activation energy, the amount of energy collisions have to have in order to have a reaction to occur. Now, while I have this on the screen, I have to go back to penmanship lessons. Actually, it's sometimes rather tricky writing on a tablet like I do. But you should know, how does the catalyst, not what is a catalyst, read the question. How does a catalyst work? And the answer is the catalyst lowers the activation energy. So the hill you have to climb is a lot smaller. And that's how catalyst works. Now, all right, first of all, I'll wait while everybody's writing this down. Because remember, Dr. White has the fastest mouse wheel finger this side and the other side of the Mississippi. If you've never seen the Mississippi, you should. Amazing river. If you've ever flown over to Mississippi, it's amazing to look down at also. Have you ever had shrimp from the Mississippi or New Orleans at the base of the Mississippi? That's a wild city to go to. Back to chemistry. Look out, it's Straight Line Wednesday. See how easily Dr. White is amused and made happy? You don't have to put X and Y there, but in case you're wondering, energy is on the Y-axis, time is on the X-axis. Now, if I have a reaction like this, this is an endothermic reaction. Endo, like in, endoskeletal, the skeleton's inside your body. Now, Dr. White's well beyond my knowledge of biology, but anyways, you have to add heat. It's on the reactant side. Now, again, total energy on one side, total energy on the other. So if I just arbitrarily say E and F is here, is G and F above or below or the same? It'll never be the same. Anyways, above or below the energy at E and F. Well, E and F has a certain amount of energy, but you also add the energy of heat. So G and H will be higher. And I'm just saying just above this line, you can make it a little less or a little more. And then it's the same hill. I have to work on my curves tonight. And the activation energy is where you start. Well, there goes my straight line day to the top of the hill. And that's for an endothermic reaction. And again, a catalyst works by lowering the activation energy. Now, something I forgot to do, bad Dr. White, when I taught you this was show you something fun. So I decided, nah, I'm not going to let them miss out on something fun. So it's time for something fun. All right, thumbs up, people. Do you see thermite on your screen? Enjoy.
This is thermite. It's a powdered mixture of iron oxide and aluminium, which when ignited burns at 2,500 degrees Celsius, which is very, very hot. This is liquid nitrogen. It's specially stored at minus 198 degrees Celsius. That's 163 degrees colder than the North Pole in winter. But is it cold enough to neutralize the intense heat of thermite? Into the slow release mechanism of a garden flower pot, the thermite is ready for action. Just like the touch paper, stand well back. The fuse triggers the irreversible thermite reaction. At scorching hot meets freezing cold, a fierce battle rages. The smoke clears, and incredibly, nothing remains. As the thermite burns at 2,500 degrees, it releases a raging torrent of molten iron, which rains down upon the liquid nitrogen, boiling the glacial mixture away in a pool of vapor and melting the cylinder, leaving just a puddle of white hot iron. A clear victory for thermite. There you go, Dan. Adding something cold to thermite doesn't cancel it out. It just makes it angry. Thermite. You won't like it. This is a car. It's been specially chosen to be destroyed because it's old, it's white, but more importantly, because it's French. The engine block is the densest part of the car. It's basically a huge lump of metal, and well, it's very hard to melt. Lucky then, the brainiacs have plenty of thermite, specially packed into the slow release mechanism of a garden flower pot. A big pile on the bonnet directly over the engine block should do the trick. To light the fuse and give this homage to French engineering the send-off it so richly deserves. The irreversible thermite reaction begins. Within seconds, the fiery concoction eats through the bonnet, spraying molten thermite into the engine beneath. The devastation continues inside until finally a torrent of white-hot liquid metal pours out of the bottom, signaling the inevitable victory for thermite. A quick check confirms a clear path of destruction through the engine. Now that the engine is melted clean through, it seems only fitting to have a go at the petrol tank. Packed into the slow-release mechanism of the garden flower pot, the thermite is ready for action. Hopped onto the roof directly above the fuel tank, the top up, and just 4 feet of family car stands between the thermite and 8 gallons of petrol. Like the touch paper, stand well back. The irreversible thermite reaction begins. Thermite produces a stream of molten iron which melts through the car in seconds. It's 2,500 degree heat, igniting the expanding petrol in a devastating fire, leaving behind a car that won't be going very far anytime soon.
You ever wondered what actors and actresses
Hope you all enjoyed that. I love it. That's the Brainiacs. And for those of you with young kids who want to have them grow up and be destructive, there are a lot more Brainiacs on YouTube, or a couple more. Now, if you notice, it's an English group and they don't like the French at that time, uh, which makes me think about a nice little story. Don't tell anybody, but back in, what was it, the early 1990s, I happened to be working for this international company that was headquartered in the Netherlands, but Anglo-Dutch. And so I'd make it to Netherlands and England a lot. I'd be there for a while. And by the way, chemists know how to party hard on company money, big time. So anyways, I was at this meeting with senior managers, and it happened to be in Belgium, and there were no French at the meeting. And after the meeting, we went out for dinner. There were about 10 or 12 of us. We knew each other, all from different countries except France. And afterward, we went to a local pub and we'll talk chemistry, ethanol, and other things. And I asked a question because I'd stayed out of France. At that time, it was well known French were not polite to Americans. And I asked at the meeting, or it wasn't a meeting, at the pub, where our group, I said, can someone tell me why French don't like Americans? And everybody started laughing. I said, what's so funny? And one of the Germans said, what makes you think they're not just rude to Americans? And he said, they don't like anybody out of their country. And that may not be true anymore, but I stayed out of France. And about that time, there were some nasty things going on, not due to terrorist things in France and Paris. So I really stayed out of France, even though I did make it there once, but I stayed out. All right, let's get back to chemistry. Oh, I forgot to ask. I'm going to use our you done poll, but did you like the video? Hold on. I'm going to do a poll. I'm going to use the are you done yet, but if I can find it. Do you like when I'm doing, it says, are you done? But think of the question, do you like me showing YouTube's? All right, looks like everybody does. Well, thank you. I'll keep on doing that when it's appropriate. I think everything's on YouTube except my high school and PhD and bachelor's degree graduation. Everything else is in there. All right, let's get back to work. Important things you should remember. Oh, my initials, the water ionization constant, and this will be given to you. I should recommend you look at test number 4, important information, before you take the test or before you start studying. Everybody see my whiteboard? Thank you. And this is important because of the ionization constant of water, because water can react with itself to form the hydronium ion concentration and the hydroxide ion concentration. If you had super X-ray vision and you looked into a glass of water, you'd see that equilibrium going on. Dr. White can't do it, but I can imagine I could if I were Superman. And not to be sexist, if you were Superwoman, you could probably do the same. All right, the other thing you should know, pH, which I'll remind you, an important scale, is minus the log of the hydronium ion concentration. Now, if the hydronium ion concentration, the important part is 1.0 times 10 to the minus x, then the pH is x. And I'm not sure, I'll have to look if I gave this important information, but I know I gave that. That's my gift to you on my test and final. That will always be true because I'm not asking you to learn how to do logs. Now, something that will not be important information is the pH scale you should know. pH goes from 0 to 14, never less than 0, more than 14. At pH 7, it's neutral. It's called neutral pH. Below 7, acidic. The lower towards 0, the more acidic a solution is. And above 7, we call that basic, also sometimes alkaline. I use basic most of the time. And the closer to 14, the more basic it is. Now, the pH of your stomach is, I don't know, 1 or 2. And what's the reason the pH of your stomach is so low? Because you have hydrochloric acid in your stomach, and it helps break down the food. But the reason the pH is low is because you have acid in your stomach. Oh, one other thing. Weak acids like citric and acetic acid, citric acid in lemons and limes taste sour. And the next time you bite into a lemon and go, ooh, that's sour, that's because of the citric acid in there. Or same thing with a lime. Lime just has less citric acid than lemons. And the next time you do shots of vinegar, I wouldn't prescribe that, but it tastes sour. Why? Because it's got an acid in there, weak acid, acetic acid. By the way, I don't know if you've been following for a couple of years. They've been selling on the internet and everywhere where they have you take apple cider vinegar pills and stuff like that. Does that work or not? Don't know. I'm a chemist, not a doctor. But what I can tell you is if you make up a sugar solution, put some apple cider vinegar in there and cut up some either cucumbers, and you make them much better than the pickles you'll ever buy. Let them sit in your refrigerator a couple of days. My friends call those the cucumbers from hell. Why? Because you can't stop eating them. Next, I found out about a month ago, I found out I don't like green peppers, but I love red peppers. If you take red peppers, you know how you clean it up, get the seeds out, cut it into small strips, put it in the same solution of sugar and apple cider vinegar, let it sit for about a week in your refrigerator. Whoa, it's dangerously good. And that's a free tip from your host, Dr. White. Why? Because acetic acid vinegar, especially the apple cider vinegar, which has other chemicals that give it that taste, make pickle it, and it's dangerously good. I've done the same thing with cabbage. That's really good stuff. And what onions I pickle too. I like raw onions better than pickled onions myself personally. All right. I see a comment or question. Hang in there. Well, Kelly asked, what do I eat with it? Well, consider it a side. And one of my favorite things that are way dangerous is uh, where you take chicken thighs, boneless, skinless chicken thighs, you cut them up into small strips, put them in seasoned flour. Seasoned flour for me is garlic powder, salt, uh, a little habanero powder, and a little more chipotle powder into eggs with the same seasoning, then into panko breadcrumbs with chipotle powder, garlic powder, and salt. Then you put them in an oven with a baking pan with oil in it and cook them at 450 minutes each way. And that's what I'll eat with that. Oh, those are good. But you can have anything you want, hot dogs, hamburgers, you name it. If you're vegan, soybeans work well with that too. I don't know if I mentioned it, but if you're a good organic chemist, you're a good cook. If someone tells you they're a good organic chemist and a bad cook, they're lying to you. Because every organic chemist I've ever met in my life, including myself, who's a good cook, is a good organic chemist, and vice versa. In about 20 days, I'll be done with this problem. I'm giving myself more room. All right, your turn. I've been hogging all the fun this morning. What happens, and notice I'm asking to the numerical value of the pH if to a beaker of water at pH 7.0, you add a few drops of concentrated KOH solution, B, a few drops of concentrated HNO3 solution. Your turn. While you're doing that, there's also a video on YouTube of the Mythbusters trying to bust what you just saw with the thermite. And they found out what the brainiacs did was true. Sometimes the brainiacs embellish things that are not totally true. The thermite, no. Since I won't use a school name or a faculty name, and it's not at COD, at another school I taught at, a teacher would go out in the field by the chemistry department building and do a thermite demonstration, which we thought was pretty gutsy and stupid, and because he used too small of a fuse. We tried to tell him that. One day he found out the hard way his fuse was too small, and he burned his hand really bad, the palm of his hand. And don't forget, it's still turn on your webcam week. All of you don't have it on. Come on, turn it on for Dr. White. You can do it. If not, I'm going to start naming names. No, I won't. That would be rude. All right. Anybody need more? Anybody done? Thumbs up, people. Thumbs up, people, without your webcam on. All right. It looks like everybody's done. Let's do this. What is KOH? It's a base. You should know that. Beginning of this chapter, and you should know the pH scale. And 7 is neutral, below 7 is acidic, and above 7 is basic. But I'm asking what happens to the numerical value. When you have water and you add a few drops of a base, that will increase the pH because you're going to make it more basic. When you add HNO3, you need to know that is an acid. And what does an acid do? It makes the pH decrease. And therefore the answer here is decrease. And for either one, you could use synonyms of either word. Decrease, you could also put lower, goes down. Those would all work for Dr. White. Your turn. If the hydronium ion concentration is 1.0 times 10 to the minus fifth, then what is the pH of the solution? And is it acidic, basic, or neutral? And I'll help you out. Have fun. As the votes come in, who's the winner? I think everybody's done, so let's get on with this. And the question is, what is the pH of a solution? And you're given this. The hydronium ion concentration, 1.0 times 10 to the minus fifth. And important information, you're given this. pH equals minus the log of the hydronium ion concentration and that is this when this is 1.0 times 10 to the minus x, the pH is x. In this case, x is 5. That's the pH. And 5 is less than 7. Anything less than 7 pH is acidic. And that's how you do it. All right, everybody see acid-base titrations on your screen? Thank you. Now, acid-base titrations is called a neutralization reaction. And neutralization reaction gets the name neutralization from the word neutral, which in pH means go to pH 7, or the concentration of the hydronium ion concentration equals the hydroxide. And that's what we call neutral. If I can spell it, hold on. Did I ever tell you I was the first one down in a spelling bee? Well, I guess I just did. All right, and this is a neutralization reaction. And acid-base titration occurs when you have a reaction, an acid, plus a base. And even though it's an equilibrium, the equilibrium is to the right, makes a salt. And this is a salt. A cation and an anion is a salt. And by adding a base to an acid or an acid to base, you neutralize it. And titrations are used to determine the molarity of an unknown acid or base. And when I say unknown concentration, you know in chemistry that's molarity. And acids and bases are titrations are done to do that, but are also done to measure certain uh, physical properties for things you buy. At one company that made certain types of, they're called carboxylic acids, every morning, and I managed a QC lab along with the research. Oh no, I'm out of tea. Uh-oh, tea withdrawal, some no. But anyways, uh, every morning we'd sample a number of production tanks and they would have to do titrations, acid-base titrations, and to determine the quality of their products. And they did about 75 every morning, the chemists. I finally realized that's not fun. So I found a way to automate it with the help of a company, and it saved a lot of work. But we did those titrations. And titrations play a role in determining the quality of various chemicals used in things you buy. So it's quite an important aspect of chemistry and making things. At one company where I was hired to solve problems in their quality control department, it came down to they were doing titrations really poorly, which gave them bad results and their product quality wasn't that good. And I told them this is what you have to do to improve it and buy certain instruments that are more accurate than what we do in a lab, in a teaching lab. And they did, and the quality went up. If I look at the clock, it's just about time for a break. So we're going to take a break, come back in 5. That would be 10:55. And Dr. White's going to do a stretch, and I'll teach you about titrations when we come back. It works, got everybody back. Why am I thinking of the name Pavlov when I blow a whistle? Never mind. All right, before I begin with titrations, there's something really important I should mention. I should have mentioned earlier. By now, I think all of you are in the age group now that you should be able to get your vaccinations for COVID-19. Get it. When it first came out, I was a little hesitant because how should I say this? I have bad reactions to different shots. One time when I got a tetanus shot, my whole left arm was paralyzed for 2 days. Trust me, I have bad reactions. So I was concerned and I held off. And then my best friend who lives in Indiana, we've been friends since freshman, sophomore year of high school. Boy, that goes back to about 65. Ooh, long time. He got both of his, no problem. So I figured, all right. I finally was able to get in where I get my medical group I belong to. It's part of this huge hospital in the northwest suburbs called NCH Group. And they had a special place to get them. I was able to get an appointment, got my first shot. Beautiful, almost nothing. Second shot, oh, it was a little irritated for about an hour or so, just going like this, the muscles were sore. Then nothing. For me, that's a miracle. And I got the Pfizer 2-shot. And therefore, I highly recommend, more than that, I urge you, get your COVID-19 vaccine shots. I think most of them in Illinois area, but don't quote me on this, are the 2-shot. I think most are Pfizer, but I'm not sure about that. And get them. If you look at the news, most of the people now getting sick with COVID-19 are in your age group. My age group are mostly vaccinated. And even with my vaccine and yesterday's announcement, I still go out with a mask on. All right. We're talking about titrations. Titrations are a neutralization reaction where you react an acid and a base together and you make a salt. And what you're doing is you're neutralizing either the acid with the base or the base with the acid to move toward a pH of 7, or when the hydronium ion concentration equals the hydroxide ion concentration. And what that means is equal amount of HA, the acid reacted, with equal amount of B if we're talking about a monoprotic acid. And a monoprotic acid or base has, the acid has this one proton. Remember, acid, proton donor, base, proton acceptor. Now, in order to do this, we use what's called an indicator, or sometimes known as a pH indicator. And this is a compound that exhibits a color depending on the pH of its surroundings. And the most famous one is phenolphthalein. And phenolphthalein changes color at pH 7. When it's below 7, it's clear. When it's exactly one molecule above 7, it turns a reddish or wine color that's quite beautiful. Now, unfortunately, tomorrow's lab, next lab, the Beyond Lab Z doesn't use phenolphthalein. I think they use phenylcresol blue or green, which goes from a yellow to blue. It's all right, but phenolphthalein is better. But in fact, I'm going to write them, see if I can get them to change it for not this semester, but the next time. Right now, they're rewriting Beyond Lab Z, so you can do it right through your browser directly. You don't have to download stuff, but that's not us. Yes, I work with companies and they also sometimes give Dr. White some money. And here's the structure of phenolphthalein, and it changes its structure when it reacts with an acid or base. And titration data are used to calculate the molarity of an acid and base solution. Now, here are some key points, and I'll explain how you use these. First of all, at neutral pH, you can calculate the moles of known acid or base based on the neutralization reaction. You can determine how many moles of an acid and base are present in the volume of the unknown acid or base. And because of that, you can determine, if you know the volume of the acid or base, the moles of sample that you calculate, and therefore calculate the molarity of the unknown acid or base. This is important. Remember, when the pH indicator changes, which is called the titration endpoint, that's when the color of the pH indicator changes. The moles of base equal the moles of acid. Because of the following equation, and we're only using monoprotic acids, the endpoint is when equal amounts of this react with equal amounts of that. And what are we talking about in amounts? In chemistry, we use moles. So at the titration endpoint, when the pH indicator changes color, moles of base equals moles of acid. It's pH practice time. And if we were in a classroom, you'd be watching me write this on the board, and I'd be telling you, hang in there. All right, 10 points. If it takes 25.0 milliliters of a 1.23 capital M, which is molar NaOH solution, to neutralize 45.1 milliliters of an HCl solution, then what is the molarity of the HCl solution? Thumbs up, people. Do y'all see what I've got on the board? I'll give you time to write it down for those who want to. All right, does everybody have it written down yet? Not yet. Aren't you glad I'm a patient instructor instead of just zooming forward? Tonight at midnight, I'll be giving speed note-taking lessons. No, I won't. All right, everybody got it down? I see not. All right, I think everybody's got it down. All right, so if you notice, we have a base and an acid. We're asking molarity. What are we being asked? Molarity, find the molarity of HCl. What are we given? 25.0 milliliters of a a 1.23 molar NaOH solution. And we're given also, we have 45 milliliters of the HCl. So how do we proceed? First of all, at neutralization, and I could have also written the pH indicator changes color. Instead of set to neutralize, you have to add 25 milliliters of 1.23 capital M NaOH solution to 45.1 milliliters of HCl to make the indicator, pH indicator, change color. It's the same thing. At neutralization, we know moles acid equals moles base. Now I'm going to teach you a shortcut. For monoprotic acids, which is all I'll ever do in this class, you can do the following. Milliliters of acid times molarity of acid equals milliliters base times molarity of base. What I've done is molarity is moles per 1,000 milliliters or liters, and it'll be on both sides. I just dropped it off, and you can get away with this trick. Now, for our case, we have, what's the acid? HCl. So how many milliliters of HCl? Well, we took the time to figure that out. 45.1 milliliters HCl. We're trying to find the molarity of HCl, and the milliliters of base up here, we took the time to figure it out, is 25 milliliters, 25.0. And the molarity of the base, sodium hydroxide, is 1.23. And now, how do we solve for molarity of HCl? Well, I've got to get rid of this milliliters. So remember, anything divided by itself. Anybody betting someday I'll use something besides the letter A? Don't. Anything divided by itself is the number 1, which means it's eliminated. So to get rid of it, I'll divide by it. But whatever I do to one side, I'll do to the other side. And notice this cancels out. I'm left with my molarity of HCl, which I'm trying to solve, is the milliliters of base times the molarity of base divided by the milliliters, in this case, of the acid. And notice it's time to use your good buddy, your good friend, unit analysis. But you thought you were done with that. And notice milliliters divided by milliliters cancel out. I'm left with molarity, which is what I want. And that's how you do it. Now, if you notice, and on test number 4, like test 3, 2, and 1, under your name, it will say, please use proper significant figures for all calculated answers. And therefore, notice 25.03 significant, 1.23, 3 significant, and 45.13. Oh no, he's in his rut again. And let me open my calculator. Let me allow you to see what I'm doing. And here's the number I get. And we haven't done it in a while. Why don't you round that off to 3 significant figures? Why steal some water? I don't have to steal, it's in my house. I'll have some water. Why does titration as thirsty work? All right, and that would round off, keep the 6, keep the 8, keep the 1, use the 8 to round off. As 5 or higher, you drop that, change the 1 to nu, and that'll be 0.682 molar HCl. And that's how you do it. All right, let me backtrack for a second and show you why I could make that assumption I did. Now here, we'd have milliliters of acid times molarity, and this won't be on a test, but in case any of you are interested, where did you get that? And this is true because of moles acid equals mole base. But why is it true? Well, let's take a look at this. You have milliliters of acid, and what's molarity? Moles of acid per 1,000 milliliters. And this is milliliters of base. What's molarity of base? Moles of base, and this you don't have to write down, per 1,000 milliliters. And notice on this side, milliliters cancel out, and you're left with moles of acid. This side, milliliters cancel out, you're left with moles of base. So this way you calculate moles of acid or base with the equations I gave you, but since it's per 1,000 milliliters, that's also the molarity. And that's why I can take this equation, which comes from this, to go to that. And that's a shortcut. 2 days later. All right, this one I'll do, then I will give you one to try on your own. And the question is, you look here, what is the molarity of a KOH solution if it takes 251 milliliters of 0.127 capital M HNO3 nitric acid solution to change the color of 312 milliliters of a KOH solution containing a pH indicator? So what are we trying to find? Molarity KOH. What are we given? We have 312 milliliters of KOH solution. We also have 251 milliliters of a 0.127 capital M, and you know that's molarity, nitric acid solution. And therefore, this is a titration. And for a titration, we know moles acid equals moles base. And from that, we know milliliters of acid times molarity of acid equals milliliters of base times molarity of base. And now remember, our acid is nitric acid, HNO3. So I have 251 milliliters of a 0.127 molar HNO3 nitric acid. That's my molarity, that's my milliliters. And my milliliters of base is 312 milliliters KOH, potassium hydroxide is a base. We're trying to find the molarity of the KOH. Now, I think I mentioned Winky D. I'm going to let you try one step. Why don't you solve on your own, solve for KOH. You don't have to do the math, but just set up the equation. And then I'll do it. Ready, set, go. By the way, in teaching, this is called fading prompts. Didn't know Dr. White is an expert in teaching. Maybe. All I'm asking you to do is solve for KOH. You don't want to do the calculation. You don't have to. Just manipulate the numbers to solve for it. Aren't you glad I'm not singing some game show music while you're doing this? Trust me, you don't want to hear me sing game show music. Guess what? Either do I. And when you're done, give me a thumbs up. All right, I see a lot of thumbs. Let's get going. We're trying to solve for this. We want it alone on one side. We have to get rid of 312. So how do we do that? Anything divided by itself is the number 1, is gone. So I'll divide this side by 312 milliliters KOH. Why? Because I want to solve for this. I want it alone. Well, whatever you do on one side, you have to do on the other side. So I will. This cancels out. I'm left with this. And you don't have to do this, but good habits, Dr. White doesn't change. I like to rewrite this. This makes me feel better. And I always like to do things that make me feel better. I don't know about you, but I do. Hopefully you like to do things that make you feel better. I better shut up because I'm not a psychologist or psychiatrist, or do I pretend to be one? And notice milliliters cancels out. We're left with molarity. And now it's time for me to go to my calculator. And if you notice, ta-da, that's the number I get. And Dr. White sends 3 significant figure, so I'll let you round that off, the 3 significant figures. Time's up. Keep the 1, keep the 0, keep the 2. Use the 1 to round off. That's my 4th significant figure, which I want to drop. And that's 4 or less, so I drop that in the 170. And the answer is 0.102. And that's how you do it. And since Dr. White always shares with my students, now you people out in the peanut gallery, oh, I haven't used that. Also, I just did a generation gap. Hello to everybody out in the peanut gallery. If you don't know what that is, go to Google and search Howdy Doody Show. And it's your turn. And the question is, what is the molarity of a HCl solution if you have to add 43.15 milliliters of a 4.555 molar NaOH solution to neutralize 85.55 milliliters of the HCl solution? And I'm going to let you have some fun. So have some fun. Do it. And while you're working on that problem, I'm going to go take a walk around the block. Take your time, enjoy, have fun. All right, I think everybody's done. Let's get moving because the clock is 2. Oh, that was a funny, sort of. All right. First of all, thumbs up, people. You see my whiteboard? Thank you. All right, let's get to work. What are we being asked? What is the molarity of an HCl solution? Remember, HCl, hydrochloric acid. And we're asked molarity HCl. Remember, capital M is molarity. What are we given? We have 85.55 milliliters of the HCl. And we also have sodium hydroxide. You should know that's a base. And we have 43.15 milliliters of 4.555. Dr. White likes the number 5 if you haven't figured that out yet. Like, anybody want to send me $5 million? No, I'm just kidding. Well, not really. Remember, send it to the Save Dr. White Foundation. All right, this is a titration because we're neutralizing something. How many milliliters of an acid reacting with how many milliliters of base to find a molarity? And we know moles at neutralization and we know this is really milliliters of acid times molarity of acid equals milliliters of base times molarity of base. And if we put in the numbers, I have here 85.55 milliliters of HCl. I'm trying to find the molarity of the HCl equals 43.15 milliliters of NaOH per 4.555. Let me move me out of the way here. Molarity NaOH. Solve for this. Want to get rid of the 85.55 milliliters. I'll divide that. Whatever I do to one side, I'll do to the other. This cancels out. Notice milliliters cancels out. And this is 4 significant 4. I got out of my rut. And now I'll go to my calculator. And this is the number I get, and round that off to 4 significant figures. I'll give you 4 seconds to do that. That's 2 point, keep the 2, keep the 4, keep the 0, keep the 3, use the 9 to round off, because these are my 4 significant. This is the 5th one to round off. As 5 or higher, drop that, increase the 3 to 4, and it's the following answer. And that's how you do it. And let's move on. We did our practice time. Let's talk about buffers. And buffers are an important concept that you should know. Everybody see buffers on the screen? All right, buffers, and here's what you should know. A buffer solution is a solution that resists major changes, meaning the pH doesn't change when small amounts of an acid or base are added to it. Now, I won't ask this one, but how do you make a buffer? You take an acid of a weak acid and its conjugate base. So if I have acetic acid, which has this structure, and its conjugate base, if you react it with sodium hydroxide, would be this, acetic acid and sodium acetate. You mix them together and you get a buffer solution. And the important thing to remember is when you add a small amount of acid or base to a buffer solution, it does not change pH. Now I'm going to do something I rarely do. I'm going to go about a whole minute or more after when I normally would end. Ah, everybody see the problem? 2 points each. If you have a buffer solution, that's key to this. As soon as you see a buffer solution, your radar should go. If you have a buffer solution at pH 7.0, then what happens to the numerical value of the pH if I add a few drops of a dilute acid? And the answer is stays the same or unchanged. Why? Because a buffer solution resists change in pH when you add a small amount of an acid. And a few drops of a dilute acid is a small amount. And B, what happens when you add a few drops of a dilute base? And the answer is same thing, stays the same or does not change. Any synonym of that phrase. Why? Because a buffer solution resists change. And I hate to scare you this, but your blood's buffered. How many of you ever heard the term buffering? And that was a medicine that was at a certain pH, so your stomach wouldn't get upset. It was buffered. And with that, I finished all the material for test number 4. And keep my promise, which is always end things about a week before the test. For those of you lab on Thursday, and for those of you lab the others on Friday, I'll be going through the equilibrium problem set. Don't forget the hand in the lab. I'm no longer going to extending deadlines. After this Saturday, you should have everything in that's due, other than the lab you're doing tomorrow is due next week. And with that, either, let's see, today's Wednesday, stop by my office hours if you want to say hello. And with that, I apologize for going a whole 3 minutes late. Sorry about that, but it's rare for Dr. White. I wanted to finish on time. And finally, I can say, gang gesund, be healthy. Don't forget to get your vaccination. If you're not fully vaccinated. Goodbye. Gang gesund.